Okay, today we are going to discuss about the rating of electrical machines. Okay, the ratings mean the sense while we are applying the load, it has been classified in 8 major categories. That is the S1 to S8. That is the 8 different categories. The S1 is the continuous duty, short time duty, intermediate periodic duty with starting, intermediate periodic duty with starting and breaking, in continuous duty with periodic loading, continuous duty with starting and breaking, continuous duty with periodic load changes. It has been classified as 8 major categories based on the applying load. Okay. So the continuous duty in the sense while we are applying the load, the machine has been operated continuously through a long period or prolonged period. Right? 24/7 if you are applying any of constant load continuously, that is the continuous duty. So you can look in the graph. So that was the load, that is the time period. Okay, that was the origin. That is the constant load you are applying throughout the day. So at that time the temperature has been raised from 0 to maximum steady state temperature. Right? 0 to maximum steady state temperature. Once it is reached the maximum steady state temperature, again it's not keep on increasing the temperature, it should be sustained at the constant. Okay, theta m. Similarly, the S2 is the short time duty. The short time duty in the sense you are applying the load the short period of time, right? Short period of time, either 30 minutes or 40 minutes throughout the day you are applying very short period of the time. That is why the name is called short time duty. The rarely we are using in the machines, right? So for this case, while you are applying the load, the temperature has been raised and it is reached the maximum steady state temperature theta m. After that, the machine is gone for rest condition, so the temperature getting the falling down from theta m to 0. That is the short time duty, right? Then continuous duty. So, sorry, the third one, the intermediate duty. The intermediate duty we can call it as intermediate periodic duty also. So, intermediate duty in the sense you are applying the load intermediately with respect to regular time interval. That is why, for example, this particular case, the T1 time period you are applying the load, the T2 time period you are not applied the load. That is why the curve is reached 0. That means the machine is gone for rest condition. Again T3, again you are applying the load, then rest condition. So likewise, if you are applied the load, that is the intermediate periodic duty. So once while you are applying the load, the temperature has been raised and it is reached to the theta m, that is the maximum steady state temperature. Again the machine it is reached 0 condition, 0 load now, so the temperature it is fall down from maximum temperature to 0. Similarly, again if you are applying the load, again the temperature is rising. So its a temperature curve will come like that. That is the intermediate periodic duty, right? Then the S4, intermediate periodic duty with the starting. The starting in the sense the same thing. You are applying the load somewhat quantity extra up to the rated current. That is the starting. So the curve is become like that. At the time of starting itself, load has been applied some quantity extra. Then again normal load. Again the machine gone for rest condition. Again it is the starting time the load was applied extra, then normal load, then it is reached 0, that is the rest period. Again the starting time the load has been applied extra. So during the starting time itself you are applying the load extra, that is why we call it as intermediate periodic duty with the starting, right? So whenever we are increasing the load, the temperature has been raised, then load is reduced, temperature is fall down, the machine is gone for rest condition, again further the temperature has been reduced. Similarly, the graph it will become like that. So similarly, the next category S5, intermediate periodic duty with the starting and the braking. The braking in the sense you are controlling the motion, right? You are applying the load in the reverse direction. That is why the curve is become like that. So only the one variation. This is the intermediate periodic duty with the starting, intermediate periodic duty with the starting and braking. So that was the braking. So it's the temperature curve become like that. So the load is reach the maximum steady state temperature theta m. Again the normal load, the temperature has been reduced. Then it is the again you are applying the load in the reverse direction. That is why the temperature is reduced further. So again machine going for rest condition. So it is reached as the temperature again further falling down from maximum temperature into 0. Right? Again the starting and normal load and the braking and the rest period. Right? That is the intermediate periodic duty with the starting and braking. Then This is for the continuous duty with a periodic loading. So the continuous duty with the periodic loading in the sense that machinist has been operated in the constant load and intermittently you are applying the load some quantity extra. That is why it is the curve for the continuous duty. Then in the time interval you are applying the some quantity of load extra. That is why the temperature curve, while you are using the continuous duty, temperature is raised from 0 to theta m1. That is the steady state temperature for the continuous duty. So again you are applying the load. So that was the theta m2. So in this case particularly the maximum steady state temperature is theta m2. For one machine is, if you are loaded the machine continuously, that should be the below rated current. Again some period of time you are applying the load somewhat extra. That is the during that time temperature has been raised theta m2. Again machine is coming for continuous duty. So the temperature falling down from theta m2 to theta m1. Again the load is applied, temperature is increased. Again it is getting down. So the curve will become like this. That is the SX continuous duty with the periodic loading. Similarly, in the continuous duty with the periodic loading, it's available the braking and the starting also. That is the continuous duty. Constant load is applied. Again, periodic loading here it is constant periodic loading we are applied. But here the braking as well as starting we are applied. This is for braking. This is for starting. The temperature curve become the same thing like that. Temperature is increased. Then load is reduced. Temperature is getting down. Again braking, again temperature is getting down and it is maintained as the constant temperature like theta m1. That is the steady state temperature for the constant load, right? Constant load, it is applicable for the continuous duty, again the starting, then normal load, again the braking. So it was varying the graph like that. Similarly, that was the 7th category. Then the last category, continuous duty with periodic load changes. So the continuous duty in the sense you are applying the load continuously, that you have to understand first. So periodic load changes in the sense you are applying the load variation, they keep on you are applying the load increasing as well as decreasing. So the load variation like that the load has been varied. So whenever the load is varying, the temperature also getting varied, load is increased, the temperature has been increased, load is reduced, the temperature is also getting down. So that is the last category, the continuous duty with the periodic load changes, right? So if you are considering this all duty, from that we can calculate the duty factor or duty ratio, that is the total operating time divided by total time. Total operating time in the sense you are applying the load from what quantity, some time interval. For example, particularly you can consider this case, the T1, T3 and T5 you are operating the load and the remaining time T2, T4 is the rest condition. So the duty ratio become like that. It is applicable for all the cases. You can using this common formula to find the duty ratio for the 8 categories. That is the operating time divided by the total time. That is the duty ratio. It is applicable for S1 to S8 all categories you can calculate it. Okay, this is the various rating of electrical machines. I mean the duty is the load. So based on this category we are classified as 8 categories. That all we discussed. If you have any doubt, you can ask me.